Hello, geometry students. I hope you are having a great week so far. I am glad that we are wrapping up the first quarter of geometry this year with our last chapter, chapter 6. We are going to do chapter 6 a little bit differently than some of the other chapters in that we are going to have 4 components to it. One is going to be a vocabulary lesson, the other is going to be a constructions lesson, and then there's going to be 2 regular lessons on topics of particular importance. So today we are going to start off by doing the vocabulary lesson. So what you should probably put at the top of your notes is chapter 6 vocab. Chapter 6 vocabulary or chapter 6 vocab. All right. So normally, again, if this were in person, I would give you some pre-printed up notes with some fill in the blanks and all that. What we're going to do to streamline this for online learning is I'm going to tell you the word and then give you the definition verbally and then draw a picture. So all that you really need to do for your actual written notes is write down the vocabulary word and then write down the picture and then listen to the verbal description. Okay. So our first word is perpendicular bisector. So let's write that down. Perpendicular bisector. Perpendicular bisector. So we've discussed this before. In fact, I think in chapter 1 we did the perpendicular bisector of a segment. So this part should just be review for you. The definition of a perpendicular bisector, and again, you don't have to write this, just listen to this part and then we'll draw the picture, is a bisector of a segment that is perpendicular to the segment. So let's go ahead and draw an example of that. If we have a segment here and we want to draw the perpendicular bisector of it, we could draw this line. We need to show that it's cutting the segment exactly in half. And then we also need to show a 90-degree angle there to show that the line and the segment are perpendicular. So this line right here would be our perpendicular bisector because it's cutting the segment in half and it's perpendicular to the segment. Now, we can also have a perpendicular bisector of a triangle. So let's write that down. Perpendicular bisector of a triangle. So it's fairly common sense, but the perpendicular bisector of a triangle is a line or line segment that passes through the midpoint of a side of a triangle and is perpendicular to that side. So for example, if we want to draw a triangle here, and we wanted to draw the perpendicular bisector of that triangle, we would put a dot in the midpoint of the triangle, and we could show a perpendicular bisector here, for example, because it would cut the side of the triangle in half, and it would have a 90-degree angle. So that we can show as a perpendicular bisector of the triangle. So it's the same concept, but one of these is bisecting a segment, the other is bisecting a side of the triangle. Okay, let's do another vocabulary word, angle bisector. Angle bisector. So again, this would also be a review of a term that we discussed in chapter 1, angle bisector. So let me write that word down for you. Angle bisector. The definition of an angle bisector is a ray is an angle bisector if it is in the interior of the angle and splits the angle into 2 congruent halves. So let's draw a picture of an angle. And then for the ray, let's use a different color. Let's use this green here. And let me do it more in the middle. That would be a little bit better. So that would be an angle bisector because it is cutting the angle in half. making two congruent smaller angles. All right, let's go ahead and read angle bisector of a triangle. So, angle bisector of a triangle. So the verbal definition is a segment that bisects an angle of the triangle and has one endpoint at a vertex of the triangle and the other endpoint at another point on the triangle. So let's go ahead and draw a picture of a triangle. And if we want to draw the angle bisector of the triangle, we would put the end of the ray, or the segment, on a vertex, and then we would show that these two angles are congruent, and that would be our angle bisector. So it has to bisect an angle of the triangle, have one endpoint at the vertex, and the other endpoint is going to be at another point on the triangle. So that is the next two vocabulary words. Now we've just got two more vocabulary words, and then we will be done with this portion of your notes. So the next word is median of a triangle. Median of a triangle. The verbal definition is a segment that joins a vertex of the triangle and the midpoint of the opposite side. So let's go ahead and draw our triangle picture. And for the median, we want to take a vertex, start there, and go to the middle of the opposite side. So the median of the triangle would be the segment from the vertex to the midpoint. And let's indicate that by putting those little tick marks there. Okay, now the last vocabulary word, altitude of a triangle, we need to leave a little bit more space for, because we need to put 3 different examples. So we're going to write altitude of a triangle. And then I'd like you to draw 3 types of triangles. Let's draw an obtuse triangle. Actually, I think I'm going to do, let's draw an acute triangle first. So let's just draw an acute triangle here. Then let's draw an obtuse triangle, like this. And then let's draw a right triangle. The reason why we need 3 examples here is because the altitude of a triangle is going to vary depending on the kind of triangle you have. The definition is the same, but how it looks is going to be different. So for the altitude of a triangle, the verbal definition is a segment from the vertex of the triangle to the line containing the opposite side and perpendicular to the line containing that side. So I think the easiest picture to see is with an acute triangle. You have to go from the vertex and then perpendicular to the opposite side. So straight down. And I like to give the example of a pilot flying an airplane above the earth. When he says, "Good afternoon, ladies and gentlemen, we are flying at an altitude of 20,000 feet, he means straight down to the ground. So this would be what we would typically see as an example of an altitude. However, if you're working with an obtuse triangle, at least one of your altitudes is going to be outside of the triangle. So for example, if I start at this vertex here, and I want to go perpendicular to the other side, I am going to have to end up going outside the triangle. So I know that looks kind of weird, but in this case, the first case, the altitude was in the triangle. In our second example, the altitude is outside the triangle because the triangle is obtuse and we're working with that particular angle. Now the third possibility is in a right triangle. In a right triangle, 2 of the altitudes are just going to be the legs of the triangle. So it would be, for instance, that height right there. So where you see the altitude can be either inside the circle, outside the circle, or on the circle, depending on what kind of triangle you have. So that is our vocabulary for chapter 6, and I'm glad that you guys listened. Thank you. Bye.